This is a video from section 11.2 in a Calculus 2 class. Let's look at the following theorem. If the summation from n equal 1 to infinity of a sub n converges, then the limit as n goes to infinity of a sub n is equal to 0. Let's look at the proof. So what we want to do is we want to let s sub n equal a sub 1 plus a sub 2 plus a sub 3 plus all the way through until a sub n. So in other words, s sub n is the sum of the first n terms of the series. S sub n minus 1 is equal to a sub 1 plus a sub 2 plus a sub 3 all the way through until a sub n minus 1. So s sub n minus 1 is the sum of the first n minus 1 terms of the series. And what I want to do is I want to take s sub n and subtract off s sub n minus 1. When I do that, notice how the a sub 1 terms cancel, the a sub 2 terms cancel, the a sub 3 terms will cancel, and we can keep going in that pattern up until a sub n minus 1. So the a sub n minus 1 terms will also cancel. And what we have left is a sub n. And so s sub n minus s sub n minus 1 is equal to a sub n. From here, since the summation from n equal 1 to infinity of a sub n converges, that's what we're given. We know that the sequence of partial sums converge by definition. So in other words, the sequence s sub n converges by definition. And because that sequence converges, we're going to let the limit as n goes to infinity of s sub n to equal s. N minus 1 goes to infinity as n goes to infinity. And so what that tells me is that the limit as n goes to infinity of s sub n minus 1 must also equal s. Now we're ready to take a look at the limit as n goes to infinity of a sub n. Well, this is equal to the limit as n goes to infinity of s sub n minus s sub n minus 1. Why? Because look over here. We established that s sub n minus s sub n minus 1 is a sub n. So this is the limit as n goes to infinity of s sub n minus s sub n minus 1. But this is the limit as n goes to infinity of s sub n minus the limit as n goes to infinity of s sub n minus 1. But this is equal to s minus s, which is equal to 0. We're done. So we can say the limit as n goes to infinity of a sub n is equal to 0. And what we have shown is that if the series from n equal 1 to infinity of a sub n converges, the limit as n goes to infinity of a sub n must equal 0. Now, we're going to write this theorem in a slightly different way that's going to be a bit more useful for us. So now, look at what this theorem says. If the series from n equal 1 to infinity of a sub n converges, then the limit as n goes to infinity of a sub n is 0. That's equivalent to saying the following. If the limit as n goes to infinity of a sub n does not equal 0, then the series, the summation, from n equal 1 to infinity of a sub n diverges. And diverges is just a fancy way to say does not converge. So now this theorem right here is called, this is called the test for divergence. It's a very quick and useful theorem, and I'll show you an example as such. Now, let's take a look at 37. Suppose we have the summation from n equal 1 to infinity of 2 plus n over 1 minus 2n. Now, what I'm going to do is look at the limit as n goes to infinity of 2 plus n over 1 minus 2n. Well, this is equal to the limit as n goes to infinity of n times 2 over n plus 1 divided by n times 1 over n minus 2. So notice I just factor out an n from the numerator and an n from the denominator. The n's cancel, and what we have is the limit as n goes to infinity of. Now, if you don't mind, before I talk about the numerator, I just took 2 over n and wrote it as 2 times 1 over n. That's it. And so we get the limit as n goes to infinity of 2 times 1 over n plus 1 divided by 1 over n minus 2. So that's right here. As n gets large, 1 over n is going to go to 0. And what we have left is 1 over negative 2, which doesn't equal 0. And so what that tells me is that the summation from n equal 1 to infinity of 2 plus n over 1 minus 2n diverges. We're done. And this is by test for divergence. We always want to state why something converges or diverges. Let's take a look at 41. Suppose we have the summation from n equal 1 to infinity of 1 over 4 plus e to the negative n. But this is the summation from n equal 1 to infinity of 1 over 4 plus 1 over e to the n. Now we're going to take a look at this limit of the nth term. So in other words, I'm going to look at the limit as n goes to infinity of 1 over 4 plus 1 over e to the n. But this is the limit as n goes to infinity of 1 over 4 plus 1 over e to the n. But this is equal to 1/4, which doesn't equal 0. And let's take a note here. If we look at the limit as n goes to infinity of 1 over e to the n, this is equal to 0 because 1 over e is greater than negative 1 and less than 1. And so that says that the summation from n equal 1 to infinity of 1 over 4 plus e to the negative n diverges by the test for divergence. We're done. Let's take a look at 47. So we have the summation from n equal 1 to infinity of arctangent of n. And I want the limit as n goes to infinity of arctangent of n. But this is equal to pi over 2, which doesn't equal 0. We're done. So what that says is that the summation from n equal 1 to infinity of arctangent of n diverges by the test for divergence. It's a really quick way to test whether a series will diverge. It's very quick. And it's one of the first tests that I will use on a series. Now, this is an important note. And this is the part that gets confusing and quickly. If the limit as n goes to infinity of a sub n equals 0, we don't we do not know anything about the summation from n equal 1 to infinity of a sub n. It can converge or it can diverge. And I want to give you an example here. If we look at the summation from n equal 1 to infinity of 1 over n, I claim this series diverges. We will learn why later. This is called the harmonic series. But the limit as n goes to infinity of 1 over n equals 0. Now let me show you something else. Suppose I have the summation from n equal 1 to infinity of 2 times 1/3 to the n minus 1. This series converges. Okay? It's a geometric series. So notice here the absolute value of r equals 1/3, which is less than 1. But if we look at the limit as n goes to infinity of 2 times 1/3 to the n minus 1, this is also equal to 0. So notice, just because the limit as n goes to infinity of that a sub n is 0, we can produce a series, a corresponding series that will either converge or diverge. So that's what I'm saying, that just because we know the limit as n goes to infinity of a sub n is 0, we can't draw any conclusions about the summation from n equal 1 to infinity of a sub n. And that'll conclude this video. It's on the test for divergence, and we did the proof and 3 examples. Thank you.